Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. Today's topic is hydrogen spectrum from the chapter atomic structure. In the hydrogen spectrum, we are going to solve some PYQ JEE main questions. So let's start. So in 2019, what is the question given? For the emission line of atomic hydrogen. So what is given? Hydrogen is given, whose atomic number is equal to 1, and it is emission line. What is that? Emission line. So emission spectrum, hydrogen spectrum is emission spectrum, and it is line spectrum, right? From which orbit n initial is equal to 8 and n final is equal to n, and we are asked a wave number. So according from Rydberg equation, what is that? Rydberg equation or Rydberg formula. Rydberg equation or Rydberg formula, what we have discussed, wave number is equal to RH into Z square 1 by n1 square minus 1 by n2 square. Okay, this is applicable for different series. We have learnt about 5 series in hydrogen spectrum: Lyman, Balmer, Paschen, Brackett and Pund. Right? Here Z is equal to 1 because hydrogen, the question asked is from hydrogen atom. So Z is equal to 1. So what I can write? Nu bar is equal to RH into 1 square 1 by n1 square minus 1 by n2 square. Right? Here what will be n1 and what will be n2? Here n1 will be final, n final. When it is de-exciting. So let us take here 1. What is this? First orbit. This is nucleus. 1, 2, 3, 4, 5, 6, 7, 8. It is coming from 8, where it is taken as n initial. From this orbit, it is moving to any of the orbit. It is not set. For example, let us take this one, n final. It is moving from 8 to this orbit, where n final is considered as n in the question. Okay, so n initial, n1 from this equation, in this equation n1 is taken as n final, because in Lyman series n1 is taken as 1, in Balmer series n1 is taken as 2, in Paschen series n1 is taken as 3. In that way, from higher energy orbit to which energy orbit, to which energy level it is coming to, that is called as n1. Finally, it is coming to which orbit? Okay, so n final, here it is mentioned as n final is equal to n. So we are taking it as a n. And what is n2? n2 is from which higher energy orbit or from which higher energy level it is returning. It is returning from which higher energy level? It is returning from, or it is coming from which energy level? n2 is equal to 8th energy level. So substitute in that equation, then what do you get? You get nu bar is equal to, substitute in equation, in this Rydberg equation, nu bar is equal to RH into 1 by n square minus 1 by 8 square. So this can be written as nu bar is equal to RH into 1 by n square minus RH by 8 square, right? Then if you equate with the equation of the straight line, then what do you get? Y is equal to mx plus c. On y-axis, what is taken? Nu bar. Okay. On x-axis, on y-axis, what is taken? Nu bar. On x-axis, what is taken? 1 by n square. That is taken 1 by n square, right? 1 by n square. Then what will be slope? Slope is m. Slope is m, that is equal to RH, positive slope. And as this is the equation of the straight line, what graph is obtained when a graph is drawn between, when a graph is drawn, see, y-axis, this is y-axis. On y-axis, what is taken? Nu bar. X-axis, what is taken? 1 by n square. 1 by n square. See, you can see here. When the plot of wave number, so this is wave number against what? 1 by n square. So we are plotting a graph between wave number and 1 by n square. Then what is the slope? Positive slope. So positive slope, and intercept is negative. Intercept is negative. Then what graph will be obtained? The graph obtained will be like this. Positive slope, negative intercept. Positive slope and negative intercept. Negative intercept means it is intersecting on negative y-axis. Negative intercept means it is intersecting on negative y-axis. Positive slope means this will be positive slope, right? When the slope is positive, you will have a graph like this. Theta less than 90. Negative slope, then you will have a graph like this, right? Theta greater than 90. So this is a negative slope and this will be positive slope. Okay. So what will be the answer now? If you see, the slope is RH. M is equal to RH. So slope is RH, not minus RH, not minus RH. And it is linear slope. The graph is linear with slope RH. Okay. So that is with the question. Next question. Let us see. So it is given in 2020. The shortest wavelength of hydrogen atom in Lyman series is lambda 1. Lambda 1. So shortest wavelength, let us take Lyman series. So Lyman series 1, 2, 3, 4, 5, infinity. Okay. If the electron return from 2 to 1, then the energy difference will be E2 minus E1, energy difference. And this will be delta E. That energy will be minimum energy. And this minimum energy will have wavelength maximum. Why? We know that E is equal to hc by lambda. Lambda is inversely proportional to energy. Okay, so this spectral line, when electron de-excites from 2 to 1, will have least energy. If the electron is de-exciting from infinity to 1, where from infinity to 1, so delta E, that is equal to E infinity minus E1, that energy. See, you are finding maximum, so energy will be maximum. So that wavelength will be minimum. So we have to know the spectral line which has least energy, which has maximum energy, right? Which has a maximum energy. So let us see here. Here asked here shortest wavelength. So minimum wavelength. Minimum wavelength means the electron is returning from infinity to 1. So here we know from Rydberg formula. What is that formula? 1 by lambda. Let us take it as Lyman series. L is equal to RH, as it is hydrogen atom. We have the formula 1 by N1 square minus 1 by N2 square. So in the question it is given that wavelength, shortest wavelength in Lyman series is considered to be as lambda 1. So 1 by lambda 1 is equal to RH into 1 by, to which energy level it is returning to? It is returning to Lyman series 1 minus 1 by, from where it is returning to? It is coming from infinity, because shortest wavelength, maximum energy difference. Maximum energy difference will be from infinity to 1. So infinity square. So then 1 by lambda 1 is equal to RH. Lambda 1 is equal to 1 by R. So we have lambda 1 is equal to 1 by RH. So this is shortest wavelength of hydrogen atom in Lyman series. Then here it is asked the longest wavelength in Balmer series is asked. The question asked is the longest wavelength. So let us take a Balmer series. Balmer series from higher energy orbit to which energy orbit the electron is de-exciting? It is de-exciting from, see, let us take 2, 3, 4, 5, infinity. From 3 to 2. So delta E is equal to E3 minus E2. This energy will be minimum and lambda will be maximum. Normally we have studied. Next, from infinity to 2. From infinity to 2. So delta E is equal to E infinity minus E2. That will be, energy will be maximum, wavelength will be minimum. What is that? Wavelength will be minimum. So what is asked in the question? Longest wavelength, that means maximum wavelength line. Maximum wavelength line will be this one. Electron de-exciting from 3 to 2. So what you take? N1 is equal to 2, N2 is equal to 3. Then from Rydberg formula, what you can write? 1 by lambda Balmer is equal to RH, same hydrogen atom. So 1 by 2 square minus 1 by 3 square. So 1 by lambda Balmer is equal to RH into 1 by 4 minus 1 by 9. Okay. Next, 1 by lambda Balmer is equal to RH into 9 fours 36. So 9 minus, right, 4 gives you 1 by lambda Balmer is equal to 5 RH by 36. Then you make this to move into numerator position. Then what do you get? Lambda Balmer series is equal to 36 by 5, 36 by 5 RH. How much? RH. So this can be written as 36 by 5 into 1 by RH. Okay. Right. So what is the question? Here it is not Balmer series of hydrogen. Balmer series of what is given? Helium. Balmer series of what is given? Helium. So in the formula, what you need to take? You have to take not hydrogen is asked. What is asked? Helium. About helium is asked. So then what do you get? RH into Z square. So RH into hydrogen helium 2 square. Atomic number of helium, for helium atomic number is equal to 2, right? So RH into 4, right? 5 by 36. Good. So 9 fours 36. So RH into 5 by 9. So if you make lambda Balmer series to move into numerator position, what you get? 9 by 5 RH. So lambda B is equal to 9 by 5 into 1 by RH, which is equal to 9 by 5 lambda 1, because 1 by RH already we have studied that it is a lambda 1. So wavelength of Balmer series will be 9 by 5 lambda 1. So this will be the answer. Okay. Next, coming to another question. So this question is asked in 2019 as well as very recent examination 2025 also. 2025 also. So let us see here. Heat treatment of muscular pain involves radiation of wavelength of about 900 nanometers. So wavelength is given as 900 nanometers. Which spectral line of hydrogen atom is suitable for this purpose? So the spectral line, electron is returning from fifth orbit to third orbit. It will release spectral line. That spectral line will have some energy. That energy is associated with some wavelength. So let us take the first option. In Paschen series, okay, given a Paschen series, it's coming from 5 to 3. So let us take a Rydberg formula. What Rydberg formula? 1 by lambda is equal to RH. So here it is given hydrogen atom. So we did not use Z square, because Z square, Z will be equal to 1 into 1 by, it is coming to third orbit, 3 square minus 1 by, it is coming from which orbit? 5 square, fifth orbit. So 1 by lambda is equal to, R value is already given, how much? 10 power 5 centimeters, but here it is given as nanometers. Let us first convert it into meters. So R value, RH given as how much? 10 power 5 per centimeter, which is equal to 10 power 5 into 1 centimeter is equal to how many meters? 10 power minus 2 meter, which is equal to, when this comes up, it becomes 10 power 7 meters. Okay. So you can write here as 10 power 7 into meter, we are taking in per meters. 10 power 7 per meters. So 1 by 9 minus 1 by 25. So 1 by lambda is equal to 10 power 7 into 25 into 9. Okay. So what do you get? 25 into 9. So here 25 minus 9. So 1 by lambda is equal to 10 power 7 into 25 minus 9 gives you 16. 16 by 25 into 9. Okay. Then lambda will be equal to, okay, 25 into 9 by 16 into 10 power minus 7. So then what you get? You get 14 approximately into 10 power minus 7 meters, which is equal to 1400 into 10 power minus 9 meter, which is equal to 1400 nanometer. So, is that the correct answer? The spectral line Paschen series, when it is moving from fifth orbit to third orbit, the spectral line is having a wavelength of 1400 nanometers. But what wavelength is involved in this treatment? 900 nanometers is involved. So this is not correct. Let us go with the Paschen series from infinity to 3. The same way, second option, let us take 1 by lambda is equal to r into 1 by 3 square minus 1 by infinity square. 1 by lambda is equal to r by 9. Lambda is equal to 9 by r. That is equal to 9 by r value already 10 power 7 per meter. That is equal to 9 into 10 power minus 7, which is equal to 900 into 10 power minus 9 meter. That is equal to 900 nanometer. So we want 900 nanometer, and this spectral line is producing having a wavelength of 900 nanometer. So this will be the correct answer. So let us go with the third option. Third option, what is given? Lyman series, infinity to 1. So 1 by lambda is equal to r into 1 by 1 minus 1 by infinity square. So 1 by lambda is equal to r. Lambda is equal to 1 by r. Lambda is equal to 1 by 10 power 7. That is equal to 10 power minus 7 meters. That is equal to 100 into 10 power minus 9 meter. That is equal to 100 nanometer. So that is not the correct option. Okay. Next, coming to fourth option, let us. Balmer series lambda to infinity to 2. What is that? Infinity to 2. So 1 by lambda is equal to r into 1 by 2 square minus 1 by infinity square. 1 by lambda is equal to r by 4. Then lambda will be equal to how much? Lambda will be equal to 4 by r, that is equal to 4 into 10 power minus 7, which is equal to 400 into 10 power minus 9 meter, that is equal to 400 nanometer. Okay, so you are having here 400 nanometers. This spectral line is having a wavelength of 400. Here it is 100 nanometers. Here it is 900 nanometers. Second one, for the first one, 1400 nanometers. So the answer will be second option. Okay. Next, coming to seeing next question, the ratio of the shortest wavelength of two spectral lines. Already we have discussed shortest wavelength means maximum energy. Shortest wavelength means maximum energy. Series, two spectral series of hydrogen spectrum is found to be about 9. That ratio is 9. That ratio is 9. So the spectral series are already discussed. Okay, so this is what infinity energy level. What is that? Infinity. These are the energy levels. shortest wavelength means maximum energy difference. If it has to maximum energy difference, always we need to take N2 is equal to infinity. What is to be taken? N2 must be taken as infinity. Okay. So let us see the first option. See the first option. In the first option, Passion is asked. So for Passion series, here N1 is equal to 3, Lyman Balmer Passion bracket fund. N2 is equal to, N1 is equal to 3, N2 is equal to infinity. The ratio of shortest wavelength. This will be the spectral line having the shortest wavelength. So then what you get? 1 by lambda is equal to R, and this is asked for which hydrogen atom. So Z will be equal to 1 for hydrogen. So 1 by 3 square minus 1 by infinity square. 1 by lambda is equal to R by 9. Right? Lambda is equal to 9 by R. Next, fund series asked. What is that? Fund. For fund series or P fund series, N1 is equal to 5, N2 is equal to infinity. Then what you take? 1 by lambda is equal to R into 1 by 5 square minus 1 by infinity square. 1 by lambda is equal to R by 25. Lambda is equal to 25 by R. If you derive the ratio, this is what lambda fund. Let us take F here. This is P. Whether lambda P by lambda F, lambda P by lambda F, or lambda F by lambda P, will it be equal to 9? Will it be equal to 9? No. So let us see that lambda P by lambda F. F is fund, right? Lambda P is 9 by R by, this is 25 by R. So what do you get? 9 by 25. So if you calculate F by P, then that will be 25 by 9. So we don't get 9. Are we getting 9? We have to get 9. So let us go with the second option. So this is not the correct answer. Next, Lyman series. N1 is equal to 1, N2 is equal to infinity. Because asked is shortest wavelength. Then 1 by lambda is equal to R into 1 by 1 square minus 1 by infinity square. So 1 by lambda is equal to R. Lambda is equal to 1 by R. Right? Next, Passion series is asked. So Passion series already we have discussed from the first option. What did we get? This is Lyman series. Passion series is how much? 9 by R. If you find the ratio, lambda P by lambda L is equal to 9 by R by 1 by R. Are we getting 9 as a ratio? Yes. So this will be the answer. That can be the answer. Coming to third option, bracket series. What series, sir? Bracket series. N1 is equal to 4, N2 is equal to infinity, right? So 1 by lambda is equal to R into 1 by 4 square minus 1 by lambda square, the infinity square. 1 by lambda is equal to R by 16. Lambda is equal to 16 by R. Okay. And already fund series we have already calculated in the option 1. Lambda P is equal to 25 by R. So this is a bracket series. Lambda BR by lambda P is equal to 16 by R by 25 by R. But you get 16 by 25. So we don't get 9 as a ratio. In the same way, what is our last one? Bomber and bracket. Fourth option, let us take bomber. Bomber series R into 1 by 2 square minus 1 by infinity square. Lambda bomber is equal to R by 4, 1 by lambda, 1 by lambda. So lambda bomber is equal to 4 by R. Next asked is bracket series. Already we have studied bracket series. How much? Lambda bracket series is equal to 16 by R. So 16 by R. So whether you divide 4 by R by 16 by R or 16 by R by 4 by R, you don't get 9. Lambda B by lambda BR is equal to 4 by R by 16 by R. So what do you get? 1 by 4. In the same way, lambda BR by lambda B, what do you get? 4 you get. So in which option the ratio is found to be 9? In the second option. So second option is the correct answer. Okay. Next question. What is when the excited state electron of hydrogen atom n is to 5 drops to ground state. Ground state means n is equal to 1. The maximum number of emission lines observed are in 2022. It is asked as an integer question. Already we have discussed one formula: maximum number of spectral lines is given by n2 minus n1 into n2 minus n1 plus 1 by 2. So here n2 is fifth orbit, it is coming to first orbit. So 5 minus 1 plus 1 by 2, it is equal to 4 into 5 by 2, 10. So there are 10 spectral lines, emission lines. What are those 10 emission lines? So let us see this. Five, 4, 3, 2, 1. 5 to directly 1. This is one spectral line. And 5 to 4 is also there. 5 to 4 and 4 to 1. Next 5 to 3, 3 to 1, 5 to 2, 2 to 1. And we have 5 to 3, 5 to 2, 5 to 3, 5 to 4. Right? Next 4 to 2 and 3 to 2 also is there. 3 to 2. Right? And 4 to 3 is also there. So these are all possible de-excitations. In this, if you see, how many are number 1, 2, 3, 4. Let us give number. In Lyman series, how many spectral lines are observed? 4 spectral lines. Because from higher energy directly to first energy level, all the spectral lines are belonging to Lyman series. Next 5, 6, 7. 5, 6, 7. So these 5, 6, 7 are what? These belong to Balmer series, right? Balmer series. So Balmer series, how many spectral lines are there? 3. Passion series. In Passion series, directly coming to third orbit. So 2 are there. 5 to 3 and 4 to 3. So 2. And brackets, how many series are there? How many spectral lines are there? 1. So totally 10. Okay. So this 10. Let us go with the next question, which is very much similar. And here in the formula, we don't have Z. It does not depend upon the type of element taken, the one electron species. It is also one electron species, but it does not depend upon the atomic number. It is given in the 2024. Given in 2024. So number of spectral lines obtained in He plus one electron species spectra when an electron makes transition from fifth excited state to first excited state will be. What is that question? From fifth excited state. Right? So let us see here. 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Okay. Now electron is in the first orbit. What is the first excited state? First excited state will be second orbit. First excited state. What is the first excited state? And that is second orbit. Okay. Second orbit. Next, coming to fifth excited state. That means second excited state, first orbit. Third orbit is second excited state. Fourth orbit is third excited state. Fifth orbit is fifth excited state. Fourth excited, and fifth excited state is the sixth orbit. So first excited state, second excited state, third excited state, fourth excited state, fifth excited state. What is fifth excited state here? Sixth orbit. So fifth excited state is sixth orbit. So N2 is equal to 6, N1 is equal to 2. So substitute in the formula N2 minus N1 into N2 minus N1 plus 1 by 2. That is equal to N2 is 6 minus 2 into 6 minus 2 plus 1 by 2. That is equal to 4, 5 by 2, 20 by 2, again 10. So what will be the answer here? 10. So here also, in the question number 5 also, the answer is 10. Okay. Next, coming to next question. For any given series of spectral lines of atomic hydrogen, let delta nu bar is equal to delta nu bar maximum minus nu bar minimum be the differences in the maximum and minimum frequencies. Minimum frequencies in centimeters. In per centimeters, the ratio. So ratio is asked. Okay. So we have studied from Rydberg formula. What did we study? Delta E is equal to E2 minus E1. Okay, so delta E, what we have written? RH into 1 by N1 square minus 1 by N2 square. Delta E means energy. What is that? Energy. Delta E is energy. And we know that E is equal to H nu. Nu is equal to E by H. Okay. So nu is equal to RH by H into 1 by N1 square minus 1 by N2 square. So when you are calculating frequency, here what is remaining same? This is Planck's constant. Planck's constant is remaining same, and Rydberg constant is also remaining same. So some of the quantities are remaining same. We don't bother about those quantities. We are very much interested with N1 square and N2 square. That is N1 and N2. So let us bother about them. So first let us calculate delta nu bar for which series. Delta nu bar is given as nu bar maximum minus nu bar minimum. Frequency. Frequency is directly proportional to energy. So more the energy difference, more the frequency. So for whom, let us take new Balmer series. Let us consider which series. First of all, let us consider Balmer series. So Balmer series. Balmer series. New maximum will be, when will be new maximum? When N1 is equal to 2, N2 is equal to infinity. Then nu bar is equal to RH by H, this is common, 1 by 2 square minus 1 by infinity square. So maximum will be equal to RH by H into 1 by 4. Okay. Next, minimum. Minimum means least energy. So least frequency. N1 is equal to 2, N2 is equal to 3. Okay. So then minimum will be equal to RH by H into 1 by 4 minus 1 by 9. Then what do you get? New minimum will be equal to RH by H into 36 pi by 36, right? So what did we calculate? One is minimum and another is maximum. We have calculated. Then if you calculate delta nu is equal to maximum how much? RH by H 1 by 4 minus RH by H 5 by 36. Okay. Then if you take common RH by H, taking common, what do you get? 1 by 4 minus 5 by 36. So which will be equal to, what is the LCM of 4 and 36? We have 36, 9 minus 5. Okay. So RH by H. So 4 by 36. You get what? Which is equal to 4 by 36. So what is this here? This is for Balmer. Let us calculate for Lyman. What is that? Lyman series. If you calculate for Lyman series, what do you get? Maximum is equal to RH by H into 1 by 1 square minus 1 by infinity square, which is equal to RH by H. That's it. Minimum will be equal to RH by H into 1 by 1 square minus. So minimum energy means when it is de-exciting from second energy level to first energy level. So 1 by, what you get, 2 square. So that is equal to 1 minus 1 by 4, 3 by 4. So RH by H into 3 by 4. So delta nu is equal to nu max minus nu minimum. Then what do you get? RH by H minus RH by H into 3 by 4. Then what do you get? 1 minus 3 by 4 gives you 1 by 4. So RH by H into 1 by 4. So delta U for Lyman series. So Lyman by Balmer is asked. Then what do you get? Lyman is equal to RH by H into 1 by 4 by Balmer is asked. RH by H into 4 by 36. So this gets cancelled. Then what do you get? 36 by 16. So what do you get? 9 4 36. 4 4 16. So what is the ratio? What we got? 9 by 4. So the answer will be 9:4. Understood? Next question is the question is asked in 2020. Question is asked in which exam? 2020 JEE main. So what is that question? For a Balmer series in the spectrum of hydrogen atom, so Balmer series. So for Balmer series, always N1 is equal to 2, right? Nu bar is equal to RH 1 by N1 square minus 1 by N2. The correct statements. As wavelength decreases, the lines in the series converge. Converge means come closer. Okay, come closer. So first option, let us speaking 1, 2, 3, 4, 5. Right? As the wavelength decreasing means energy is increasing. Energy is increasing. So let us take first from 2 to this is 1, 2, 3, 4, 5. So 3 to 2. First one is first spectral line in Balmer series is what? 3 to 2. The next one is 4 to 2. The next one is 5 to 2. Okay. 5 to 2. So when you speak 3 to 2, 4 to 2, 5 to 2, in this way 6 to 2. So on moving from here to here, what is increasing? Energy is increasing, wavelength is decreasing. So wavelength is decreasing. When wavelength is decreasing, energy is increasing, the difference of energies. See, 5 to 2 energy. In the same way, 6 to 2. What is this? 6 to 2. So 6 to 2, it releases spectral line. 5 to 2, it releases another spectral line. As their energies are very much, the difference of energies are very much less, the spectral lines are very much closer. They will become very close. So on moving away, that means when the wave energy is increasing, the difference of the energy levels, energy is increasing, wavelength decreases. When the wavelength decreases, the difference in the energies, as the difference in the energies is less, the spectral lines released will be very closer. That is the meaning here. As the wavelength decreases, the lines in the series converge. That means they will be very closer because their energy differences is very much less. If you move again 6 to 2, 7 to 2, the energy will be greater, but the difference in the energy between these two spectral lines will be less. Which two spectral lines? 6 to 2 and 7 to 2. Two spectral lines are produced. These two spectral lines, energy difference is less. So they will be very much closer. That means they are converging. They are coming very closer. So this option will be correct. So N1 is equal to 2. Already we have seen that N1 is equal to 2. longest wavelength. So lambda will be maximum. If lambda must be maximum, then energy must be minimum. So minimum energy spectral line will be n2 will be 3, n1 is equal to 2, right? n1 is equal to 2 and n2 is equal to 3. This will be the spectral line having the least energy and maximum wavelength. Okay. So these two are also correct. The ionization energy of hydrogen can be calculated from the wave number of these lines. So from the wave number we can calculate wavelength, we can calculate frequency, but we cannot calculate ionization energy. So this is not possible. So the answer will be, okay, first option. So these are the different types of questions asked in JEE mains from the topic hydrogen spectrum of atomic structure. So in the next lecture we shall discuss PYQ of other topic.